Going to learn about belief networks and some basic terminologies used in them. Number one is, what is the meaning of when two variables are independent? So when x and y are independent of each other, that means the occurrence of one does not affect the occurrence of the other, and their probabilities are also exclusive. For instance, the probability of occurrence of x does not affect the probability of occurrence of y. This is also known as marginal independence. Now, what is the meaning of conditional independence? So conditional independency involves three variables, x, y, and z, or a, b, and c. So conditional independence is basically that given a knowledge of a third variable, the independence of two variables does not affect each other. When a and b are conditionally independent given c, it indicates that once c's value is known, neither a's occurrence nor its value adds any new knowledge to b and vice versa. In terms of mathematics, this is how we write it, that probability of a given b and c, the probability of a and c are mutually exclusive. So they don't affect each other. Now, what is this independence assumption in belief networks? Why do we use it, right? So it's basically to reduce the complexities and to make a model more effective and the inference more effective in the probabilistic graphic models. The independence assumption in belief network states that a variable is conditionally independent of its parents and non-descendants. This assumption facilitates the storage and computation of joint probabilities with belief networks, where nodes stands in for random variables and direct edges for probabilistic dependencies. Now, in practical terms, the independence assumption states that a variable becomes conditionally independent of all other variables in the network that are not its descendants once the values of its parents are known. Right? Again, this assumption reduces the complex joint probability distributions to simpler conditional probabilities, allowing for more effective modeling and inference in probabilistic graphic models. Now we're given a sample problem, and then we're going to run it in AI space and observe different conditions. Here I already have it. So the number one is we're going to solve tab, and we're going to query the smoke variable without observing anything. So we're using this brief one, and there we go. Now the probability that the smoke occurs is 0.0189. We do not observe anything for now. So that's the answer for our question D. The next one is observe that fire is true. So we are going to make an observation that the fire is true. Okay, and then we're going to query smoke. Now the probability is 0.9 because smoke depends on fire. And then we are going to observe that fire and alarm both are true. Right? And now we're going to observe smoke. Now we're going to query smoke. It remains the same because it only depends on fire and not an alarm, right? And then we have another one where we're going to check the independencies, the conditional independencies, and we're gonna check it using the solve tab. We're going to independence quiz, there you go, and then we're going to ask the applet, ask a question. We are going to see that if leaving is leaving conditionally independent of fire given alarm. So we're gonna get the answer, which is true, and then we're going to do another one, ask a question, is leaving conditionally independent of report given alarm. Then you get the answer, which is obviously false. So this helps you understand the concept of independence, conditional independence, in AI, in belief networks. So yes, we can play around the applet and make ourselves comfortable. Thank you.